Welcome to Energy Talks, a regular podcast series featuring expert discussions on power system testing, data management, cybersecurity, and important trends in the power industry. My name is Scott Williams from the podcast team at OMICRON, and I will be your host. Hello, everyone. In this episode, OMICRON partial discharge measurement and analysis expert Caspar Steineke offers a first-hand account of the last 20 years of OMICRON MPD technology and how it has revolutionized partial discharge testing, also known as PD testing, worldwide. Caspar describes how MPD technology began 20 years ago in response to industry requirements for functionality that had not existed before, such as synchronous, multi-channel, and highly stable, repeatable PD measurements with data recording for reliable post-analysis. Caspar highlights how engaging with users, listening carefully to their needs and application requirements, played an essential role in MPD development and has resulted in many groundbreaking features that make PD measurement and analysis easier and more reliable for a diverse range of PD testing applications. Caspar also describes the important milestones in the evolution of MPD technology over the years. Caspar has been a guest before in Energy Talks, such as episode number 72, about the essentials of partial discharge testing on electrical equipment. Hello, Caspar. Thank you for joining me again as a guest on Energy Talks to learn about the history of MPD technology and how it has made an impact on PD testing.
Hi, Scott. Thanks for having me.
OMICRON celebrated its 40th anniversary this past year in 2024. In the last 20 years of that time, MPD technology was developed to become a groundbreaking solution for partial discharge testing and analysis. Caspar, how have you been involved in this chapter of OMICRON history?
Well, test and measuring instrumentation has really always been my passion, and this is going back to my early days of tinkering with electronics and software as a kid, and then my time in university and research. And so we started a company initially around medical and aerospace, and we even built a scientific payload for the International Space Station. And then, inspired by our research and some evolving customer needs, I'll explain that later, with these customers mostly being our friends and close associates at the time, we felt that the area of partial discharge testing required a complete overhaul. So once we had then developed the MPD technology, we had a real problem. The technology was generating a lot of interest and was really taking off while we were kind of overstretched dealing with worldwide sales. So at that time, we were approached by Michael Kruger from OMICRON, and things got rolling. So we checked them being OMICRON at the time, we checked them out and vice versa. And we were really fascinated by the fact that OMICRON felt like a larger version of our smaller company, kind of sharing the same ideals and passion for technology. So it was really an instant fit. And in the period of 2006 to 2009, we became a part of OMICRON and have been ever since.
Would you consider yourself passionate about PD testing, and if so, why?
Absolutely. Other than always having been interested in instrumentation and the underlying architectures, I have been living and breathing PD testing for a good 20 years now. It's a fascinating field in that we keep discovering new effects and ways to measure them more efficiently. But it's also been a complete team effort all along. And while the team has been expanding and rejuvenating, virtually all of the original members are still on board. And it has been and is a wonderful journey. Being in this together is what has really driven our passion and made us challenge each other and ourselves.
Caspar, we've talked about partial discharge testing in a previous episode. Could you remind our listeners what exactly is partial discharge and why should it be tested?
Sure. Partial discharge is a localized breakdown of a dielectric system, that is the insulating system of an electrical acid. And partial discharge is an important precursor to total breakdown, and it's one of the very few indicators that we have for an eventual and impending breakdown. So it's a very important diagnostic tool. It's an important tool in quality assurance in industry. So after manufacturing an acid, it's important on-site in the field when periodically testing acids or acids that are under suspicion. So PD is a very useful tool in evaluating electrical energy acids.
When did partial discharge testing really begin, and what was it like then?
Well, PD is actually very old. It started very early on, and with people using shortwave receivers, and then testing for what was initially called radio interference voltage. And then it became more and more accepted and standardized, and it was made into a specific measuring instrument. So we're talking, this is between the 1940s and 60s. And then in the 1960s, you gradually had real standards. And finally, IEC 6270, which really made this official. And, since then, we've seen a certain evolution. These were originally analog testing instruments, and using analog components with certain behaviors like over age, they would drift, they would change. And so the initial answer was each measurement had to be calibrated. And so for each measurement, you had to apply a calibrator to your acid, set up your test instrument, and the whole measurement was made traceable and calibrated through that calibrator, and then that very specific setup. Well, this, of course, could not last. We have digital signal processing now. We have filters that are deterministic. That is, you can have a filter setup that's perfectly repeatable. You have a filter setup that can be incorporated into the overall signal processing strategy, and thus make perfectly repeatable and absolute measurements, no matter what you set your filter to. And this is all necessary evolution. And in addition to that, we have IoT, Internet of Things. So we're used to instruments being detached from the user. That was not initially the case. So when we started with this, people were still used to having your 19-inch rack with a big instrument and then a cable running into the test field. Now instruments have kind of become small, and they're sitting somewhere close to the acid, which is hugely beneficial for many, many reasons. Safety, ground loops, and others. And then you run a data connection from there to the user. And that is, of course, now perfectly natural and normal to people. But 20 years ago was not.
Very good. So the development of MPD technology really evolved with the way technology was going and needed to go.
Absolutely. And that's something that keeps, driving us. And I'm just getting enthusiastic when I see certain new components evolving. Let's say new chips, new ADCs or high-powered signal processing architectures that become possible. So what has powered the initial development of the MPD was the mobile communications revolution. The components that we had at our disposal only really came with all those mobile base stations and other components for mobile communications networks. So before, they were just completely exotic. And to this very day, we love getting our hands on new interesting components and applying them to a problem that we certainly understand very well by now.
Caspar, in addition to advancements in technology, what other drivers led to the original development of MPD technology?
Yeah, the original drivers were really twofold. On the one hand, we had the first large-scale 400 kV XLPE cables that were about to be deployed near our base in Berlin. And while, when you do this, the individual cable lengths came pre-tested from the factory, the joints were obviously installed on site. So you have these really large cables, have to get them into a tunnel, and then you assemble the joints and such. So for commissioning, the utility customer and operator of the system required a simultaneous measurement of partial discharge on all joints while conducting high voltage tests on the entire cable. No existing technology was able to provide geographically distributed, real-time, accurate PD testing at multiple unsupervised sites. This led to the fiber optic connection and synchronization along with the multi-channel capability that the MPD now features and that most of you are probably aware of. And then our previous experience with space technology, where you cannot repeat experiments and so have to record whatever data you can get hold of, is quite similar to high voltage testing, which by its very nature can be destructive. So if and when you have to do a post-mortem analysis, it really helps to be able to record all data in real time and then be able to analyze it all later on. And that's kind of like the flight recorder of PD. So that was one. This is all about these cables. And then on the other hand, the challenge was accurately testing large rotating machines in the so-called hot zone of nuclear power plants. And the main issue here was that existing PD measuring systems at the time had to be recalibrated prior to each measurement. But how do you do that when your asset is only fully accessible every 3 years during major maintenance? So the measuring tap for that asset is outside the hot zone, so you can perform regular measurements. But again, for calibration, you need full access. And so when you have to calibrate every measurement, that's a no-go. So we had to come up with a measuring solution that is completely long-term stable, performs near-perfect repeatable measurements, and can recall prior calibrations for individual assets. And this really required the instrument to be able to perform absolute measurements. That is, measure the charge in the partial discharge accurately and absolutely over a wide and configurable frequency range and over many years of use with only a factory calibration.
That's interesting. Caspar, what has been significant about the last 20 years of development of MPD technology? You have mentioned some of the main drivers that led to the development of the technology. Are there any major milestones that contributed to its evolution?
Well, without any doubt, the most important milestone has been the release of our MPD 800 system, which features a myriad of improvements and pretty much bundles most of the lessons that we learned along the way, many of which were inspired by very specific challenges that our customers were facing. So to me, it's extremely satisfying when you can offer a proper solution to all the little and not so little wishes that had been expressed by our user community all along. So speaking of which, looking back, what I found most significant in these 20 years is the gradual buildup of that huge, diverse, and global user community. We've been living amongst that community and have been talking to them constantly. And that has really informed a lot of our development decisions and our direction. So that, to me, is really the most important development over these 20 years.
How has user reception to and use of MPD technology changed over the years, Caspar?
Well, as with any technology that is initially disruptive, it's been a path from maverick to wide acceptance. And, let's be real about being quote unquote disruptive. I mean, the term's a little overused by tech companies. And we're really only operating here in a very highly specialized engineering discipline. But, within that community and that specific field, it really has been disruptive. So initially, the MPD system looked very different to all those existing solutions. And it took quite a bit of convincing, which surprisingly wasn't that hard. So once people experienced the system on their premises and it was solving their PD testing problems, most of the convincing had already been done. So we then provided bridges for these users so that people could leverage their experience with older systems, like having certain visualizations that people in the industry were used to, like, the ellipse representation comes to mind. And that has all really changed as over time, this technology has become generally accepted and has in many cases even set standards and benchmarks. So now our focus is clearly on innovation and usability, and we're seeing a great response to that.
In which ways has MPD technology changed how users diagnose their electrical equipment?
Well, MPD technology in general has made PD testing way more accessible. So on the one hand, it's quick and easy to set up a simple pass-fail test alongside a production line with greatly reduced shielding requirements due to the variable filtering that the MPD provides, and those user models that do not expose more complexity than is needed. So that solution can then be operated with only minor training while still maintaining a completely standard compliant measurement that's fully traceable and provides the quality documentation that these users need. On the other hand, in the MPD, there is a lot of functionality that specialists and experts will appreciate, and that helps them solve the most complex on-site and lab testing challenges. So where you needed a range of equipment before, we now provide an extremely compact and complete solution. And that has certainly changed the playing field.
How has MPD technology evolved to meet user requirements over the years?
Well, that's a big one. But there's a real short answer to that. We listened. As I said before, it's the user community and the many, many interesting, often actually fascinating use cases that we get to see thanks to our customers. And, we meet them on site at many conferences and trade shows and during the PD training that we provide. So our people in PD services are great, and they're doing that all the time, and they keep talking to customers, and that provides so much valuable information. So the MPD 800 really represents a lot of listening. It looks beautiful, and it's highly responsive. The UI, the user interface, it works, on small screens and big screens. It features, and this is hugely important, it features user roles and exposes only the complexity that is required for a task. Because before, we had users that found PD testing to be too complex and difficult. So now a lead engineer can set up a testing situation, and then you can have someone that's relatively inexperienced perform the day-to-day testing. It's also perfectly multilingual. That's really important, because it is used worldwide. Then there are workflows available now that guide a user through certain repetitive tasks, like in a cable factory or, certain types of transformer testing and such. And then you have a robustness in the system itself and handling it, like the types of connectors that we're using, how we do the enclosures, and that has all seen a lot of improvement over time. And then, there is general technological progress, and that's really what we do. So we have higher bandwidth, we have higher accuracy, we have 2 channels per device, and there's many, many other improvements. And I could kind of keep going with this way longer than this interview is supposed to last. So in general, while the focus from a user perspective has been many, many usability improvements, there is actually also a completely new engine under the hood.
Very good. So you've talked time and time again about the importance of listening to customers. Could you tell me more about how you went about gathering customer feedback and learning from their field experience and how that played a role in MPD technology development.
Yeah, this is really a recurring theme here, but that's perfectly accurate because it's so important. Well, the biggest role of all, that's what our customers have actually played in this. And it is, for example, our PD services team, which is, with our customers 24/7, and our development engineers that regularly go on site and experience the actual use of their equipment. And so most features are inspired by actual customer stories. And they don't come from thin air. They come from actual problems that we have seen on site throughout the entire world. And sometimes we do come up with something that's completely new just by ourselves and from our research and lab experience and our innovation process. But even with those features, we do try them out with specific customers who we think might like them. And if they're not validated by customer experience, you're not ever going to see them. So the customer really does play a very central role here.
Thank you for that, Caspar. What is different about MPD technology, making it a universal PD testing solution?
Well, MPD devices are, first and foremost, small and compact. They're kind of like the Swiss pocket knife of PD testing. So there is so much functionality, most of which, admittedly, is not of use to most users, but when you need it, it's there. So in test and measurement, most of you will know, it's the previous unknowns that really delay operations. So there's, things that are popping up that you just weren't expecting. And then to have a feature when you need it is incredibly valuable. And that's why the MPD is so feature rich. This is also why we have the user roles, so that you're not overwhelmed by, all those features and all that functionality. So typically you're operating in a much simpler environment. When you need it, you have these features. And also that functionality is all integrated. That is, most of it does not require any additional accessories. And that's very much unlike other solutions in the market. And that makes MPD technology a great tool for on-site operations because you only need to carry a smaller amount of gear. And finally, we have other solutions that integrate or cooperate with MPD technology. So it's an ecosystem like the UHF 800, which is very much the leading solution for UHF testing. That's for GIS or specific terminations and such. And then we have a solution for acoustic localization that also works in conjunction with the MPD. And we have primary test sets in the CPC range that can be used for powering some of these tests. So it's an ecosystem approach, and it's also the Swiss pocket knife.
Caspar, how does MPD technology reflect Omicron's priority to develop solutions that make power system testing more efficient, safe, and reliable for users?
Well, again, that's a pretty short and easy answer. So it's efficient because there is functionality with user roles, reduced complexity, there are workflows that guide you, and it's all multilingual. And then it's safe because we have optical fibers, so users stay at a safe distance from high voltage. And then it's reliable because it's tried and tested. We have a lot of QA when we develop, and we test this extensively with early customers before releasing it into the general market. Then, of course, there's always recording functionality. That's also for, making it reliable, for keeping all the data that you might ever need.
Thank you, Caspar. How do you see PD testing evolving in the future?
Well, what we've already seen is that it's becoming more mainstream. To a large degree, it's becoming more accessible. And in very many cases, it's required because, customers demand PD testing when they purchase assets. And then in the future, we will see algorithms and data processing becoming better and more integrated with other diagnostic tools. So I would certainly expect there to be a much better and clearer picture of an asset's health in that future. So that's something we're really looking forward to, like data fusion from various sources, looking at assets. And PD is a very important component in that. And then with factory and on-site testing, there will be different approaches that are much more closely linked, like permanent and automated observation, like monitoring that can then be related to initial factory data and such. So much of this is really data-driven. Much of this is driven by a permanent and real-time picture of assets in actual operation.
So in which ways will MPD technology continue to meet the needs of users in the industry?
We're constantly investing in research. We're trying out new features. We're doing a lot of improvements. And most important of all, we keep listening. So aside from that, we're definitely also PD geeks, and we're really enjoying that part of it. So I'm very passionate about the underlying technology, and we have a great and wonderful team. And we will, as a team, keep working with our wonderful and great user community.
Caspar, thank you for joining me to share your memories about the history and evolution of MPD technology in this episode of Energy Talks.
Thank you, Scott.
And a big thank you to our audience for listening to this and other episodes of Energy Talks. We always welcome your questions and feedback. Please send us an email to podcast@omicronenergy.com. Omicron has several years of experience in power system testing, data management, and cybersecurity, and offers a matching solution for your application. For more information, visit our website at omicronenergy.com. Please join us for the next episode of Energy Talks. Goodbye for now, everyone.